All right, let's take a look at the 1-5 notes. So a lot of these vocab you can look up on your own. We'll run through them real quick, but you always do have the reference of your textbook. All of these are located in there in both the glossary as well as in the section 1.5. So first thing is adjacent angles. Adjacent angles basically share a vertex, one side, and no interior points. All right, so an example of adjacent angles would be if we had angle ABC here, all right, and then we drew in angle CBD. All right, these two angles, angle 1 here and angle 2 here, are adjacent angles. All right, examples that would not work would be like if I had something like this. Let's just use the same picture. All right, where I have A, B, and D, and then I have C through the middle. All right, if I was talking about angles A, B, D, and angle A, B, C, right, those two are non-adjacent because they share the interior points in this region here. Whereas in my example, it's angle ABC and angle CBD are adjacent angles. All right, so adjacent angles share a vertex and one side and no interior points. All right, a linear pair, these are adjacent angles that form a straight line or a straight angle, whichever way you want to think of it. All right, so this would be an example if I had a straight line here, A, we'll toss a B in there, and C. All right, so I have that. And the two angles are adjacent, so I draw something like this with a D. All right, notice how they form a straight line. So I have angle A, B, D, and angle D, B, C. All right, they're considered a linear pair because they form a straight line. Excuse me. We'll see later that the sum is 180, but they form a straight line is the key idea. So counterexample would be something like if that one side was not a straight line. So if I had A, B, C, like in this picture, and then I broke them here with ray BD, now, sorry about that, now angle ABD and angle DBC are not, so they would be a counterexample. So again, example, counterexample. All right, vertical angles. These are two angles formed by intersecting lines. Two angles formed by intersecting lines that are non-adjacent. All right, so an example here would be if I drew two intersecting lines. Let's call this A, B, and toss a C in the middle. And then call this one D, F. All right, if I label these angles 1 and 2, all right, angle 1 and angle 2 are vertical angles. All right, they're formed by intersecting lines, but they're not adjacent. Counterexample, if I do the same picture here, so I still have D, C, F, and A, C, B. All right, if I number these 1, 2, 3, and 4, all right, angle 1 and angle 4 would not be vertical because they're adjacent to each other. So again, formed by two intersecting lines, but they have to be opposite. So we can consider this top angle and this bottom angle. That would be one option. All right, another option would be this angle and this angle, but they can't be adjacent. All right, jumping to the next, complementary angles. All right, this is two angles whose measures add to 90 degrees. All right, so an example would be if we had like a 30-degree angle over here, and we'll call that A. We had a 60-degree angle over here, we'll call it B. We could say angle A and angle B are complementary angles. All right. So a lot of times we'll abbreviate that COMP, and then a little angle symbol with an apostrophe S for complementary angles. All right, a counterexample would be if I had the 30-degree angle here, and my other angle was 70 degrees. All right, and we'll say A and B. So in this one, A and B would not be complementary because their angles don't sum to 90 degrees. If I jump to this next one, supplementary, this is two angles whose measures add to 180. All right, so this would be, an example would be if I had an 80-degree angle and a 100-degree angle. All right, they don't have to be adjacent, so A and B, we'd have angle A and angle B are supplementary angles, and again, we abbreviate that. Counterexample would be two that don't. So if I did 30 degrees and 110 degrees, all right, that would be a counterexample because they don't add to 180. Last and not least is perpendicular lines. Lines that intersect to form right angles, all right, or an angle that has the size of 90 degrees. So an example here would be if I had line L and line M, as long as I had a right angle there, those two lines are perpendicular. So we could say L is perpendicular, it's like an upside down T, to M. All right. Counterexample would be if I had line L and then line M was at an angle like this, all right, where let's say this was like 25 degrees, then those would not be perpendicular. All right, so that was the vocab. Sorry that was a little bit longer video. Run through a couple examples in the next segment.